Hello, this is Brother Tony, and we're in section 4.4, f of x terminology, systems, and models of equations. Okay, so let's begin. So what are we going to do today? Define and understand f of x terminology, show you how to evaluate f of x, and then understand systems of equations as mathematical models. So strap in, and let's get going. First one, define and understand f of x terminology. So we have two equations, two linear equations, y equals 0.75x plus 3 and y equals 2.5x minus 5. Now if somebody asks you the question, what does y equal when x is 4? Right now you could not answer that question. And why is that? Because you have two equations, both starting with y, the dependent variable is y. So what do? What we do is we rename the equation. Instead of y we say f of x, so the function of x, or f of x, equals 0.75x plus 3. The second one, we make another one, g of x. We could just as easily said h of x, t of x, s of x, whatever. But g of x equals 2.5x minus 5. So now, when somebody asks, what does y equal, or what does f of x equal, when x is 4. Here's the terminology. If we wanted to evaluate the f of x equation when x is 4, we would write this as f of 4 equals 0.75 times 4, because what are we doing? We're substituting 4 in for x plus 3. And what does that equal? 0.75 times 4 is 3 plus 3 is 6. So f when x equals 4, f of 4 for this equation equals 6. It would equal something totally different if you put 4 in for g of x. G of 4 equals 2.5 times 4 minus 5. 10 minus 5 is 5. So g of 4 equals 5. So for your notes, here we are. Here is the definition of f of x. Please write that down in your notebook, just like you're writing down everything else in this video. Okay, now that we know the terminology, the second thing we want to do is make sure that we can evaluate f of x, g of x, whatever. The first one, the first example has f of x when x is 8 divided by g of x when x is 10. So how would we write this? We would go 0.75 times 8 plus 3 divided by 2.5 times 10 minus 5. So the top, 0.75 times 8. So that's 6 plus 3 is 9. Divided by 2.5 times 10, so that's 25 minus 5, which would be 20. So the answer to example 1 is 9 over 20. Now example 2 is a bit more difficult, but only conceptually. We have, you would call this f of g when x equals 4. So just like order of operations, we work from the inside out. So here's what we do first. We evaluate g of x when x equals 4. So what do we have? G of 4 equals 2.5 times 4 minus 5. 10 minus 5, so that equals 5. So now, what do? We substitute this value in for g of x when x equals 4. So now what we have is f of x when x is 5. What does that equal? 0.75 times 5 plus 3. So 3.75 plus 3, 6.75. So f of g when x is 4 is that value. Remember, work from the inside to evaluate the first one, then whatever answer you get in the first, you substitute it into the second one. And if there's 2 equations or 3 or 4, you keep doing the exact same thing. Inside to outside. So the third point we want to go over in this lecture is that systems of equations represent mathematical models. And the first thing we do, if we have 2 equations, which are now a system of equation, instead of y equals 0.75x plus 3, it's f of x and g of x. And if we want to see where they're equal, first thing we do is put them in slope-intercept form, which is what we have. We graph them, and then we see where the 2 intersect, and you'll see the x-coordinate and the y-coordinate. And basically it gives it to the millionth of a decimal point. We see the slope of both would be, or the slope of the yellow line would be 0.75. So remember, these 2 equations represent lines that are graphed, and the intersection is where those 2 are equal. Okay, so let's go over this sample problem. Air conditioning problem, you have a choice of 2 units. Take a couple seconds and read this fully before you continue. Okay, now that you've read it, we have 2 types of equations, or 2 equations, f of x and g of x. So let's actually create those equations. So f of x for the less expensive air conditioner, we know that it costs $60 a month, so your slope is 60, because slope is rate of change. So for every month, and that's represented as x, it will cost you $60 to operate that. But the y-intercept is $1,800, because at 0 months it costs $1,800 to purchase that air conditioner. So this is for the less expensive, the cheaper air conditioner. G of x represents the more expensive one. The rate of change, or the slope, is every month that you own and operate that, it costs you $50. However, to purchase the more expensive one and the more efficient one, it is $2,600 initially. So that's that. So if you did, after 100 months, f of 100, so 60 times 100, 6,000 plus 1,800, so that would equal $7,800. For g of x, when it's 100, so 50 times 100, 5,000, plus 2,600, so that's $7,600. Now the question is, at what month will these 2 functions be equal? Well, we can solve it a number of ways, but as we know, we like to do it graphically if we can. So let's do that. So I got in a good grapher and graphed both functions. And where the 2 lines intersect, and the intersection is at 80 and 6,600, what does that mean? So in 80 months, both units will have a total cost of $6,600. So that is when both units are, the total cost has been equal. So if you can keep those 2 units for more than 80 months, so what is 80 months? So 12 months in a year, so what is that, 7 times 12 is 8. So if you can keep this longer than 7 years in good working order, and the cost of maintenance is exactly the same, any month past 80, you will be saving money. And that's what the intersection right here says. If we look at the slope of the 2 lines, we would see the cheaper, the least expensive air conditioner has a steeper slope, meaning every month it costs more. And what do you mean? What is the slope? It was 60 of the more expensive one versus the slope is 50 of the cheaper one. So this can be useful when you're actually evaluating long-term, or what we would consider these to be capital purchases, more than 5 years or so. Same thing with the car. Okay, so to wrap it up, we did systems of linear equations, f of x terminology, systems, and models. Take good notes, and I'll see you in class.